Okay, we were taking another integral. This one's sent to me by Sid. We've got the integral of 1 plus x sine x plus 1 minus x cos x over 1 plus sine 2x dx. Okay, right away I was thinking of some kind of product rule or quotient rule with this. The thing, you notice first that we've got the derivative of sine as cosine. This is really similar, 1 plus x, 1 minus x. The thing is, what do we do with this denominator? And if it's going to be the quotient rule, we're going to want something squared. Well, what I was thinking is there is an identity that I always forget for this, so I just always kind of work it out in reverse. If you start with sine x plus cos x. If I square that out, what's going to happen is you have sine squared x plus cosine squared x, but that's just going to be a 1. And then for the middle terms, we're going to have plus 2 sine x cos x. So this identity really cleans it up quite a bit. But then for this, 2 sine x cos x, that's going to be the same thing as sine 2x, so I can write this as 1 plus sine of 2x. But this right here, this is just our denominator, so going in reverse, we can use this thing instead, and now we have something squared, and now maybe we can use the quotient rule. Okay, now we have the quotient rule over here to the right, and it's starting to look more like this, where we've got something squared in the denominator now. There's a few problems still, first of all, this plus sign, because in the quotient rule, we are separated by a minus sign. And then also, the derivative of 1 plus x is not going to be 1 minus x or vice versa, so that we still have a little bit of work to do. But what I usually like to start with is the thing that we seem to know here is that matching with this formula, this denominator, sine x plus cosine x, this is just going to be our g. And then, of course, we can go ahead and take a derivative of that to find out what g prime is going to be. So doing that, derivative of sine is going to be cosine. Derivative of cosine is going to be minus sine. So at least we see that we're producing sines and cosines for the numerator. What I can do is kind of use this formula, just looking at the numerator. Let's use f prime g minus fg prime. And what I'll do is write this out is, we're saying we want f prime times g minus some f that we don't know yet times this g prime. And what we want is for somehow this to be equal to our whole numerator right here. Now this can sometimes be kind of hard to figure out, but what we know we've got sine here and here. And so maybe we can rearrange this and just figure out the coefficient. The same thing, we have cosine here and here. So what I'm going to do is just totally rearrange this based on the sine, try to get it to look like this. So if I do that, putting the sines together, we have a sine x, and then in front we're going to have f prime as the coefficient here, and then here minus times minus is plus, this is going to be a plus f over here. And then for the second part, let's do the same thing with our cosine. So we have cosine x, we have an f prime. If we distribute this in here, we're going to have an f prime on it here, and then this is going to be a minus f on it here. But then comparing to what we have up here, for this to work, we're going to want f prime plus f to be equal to this 1 plus x right here. And then we're going to want f prime minus f to become 1 minus x. But I think that makes it pretty clear, because we can kind of just go 1 to 1 and look at it. And for this to work, we're going to want f to be just equal to this x value. And then, we could take a derivative of x and get 1, but also just looking at it, we need f prime to be 1. So it turns out we have everything over here we need for the quotient rule. It's just kind of out of order. The numerator is all scrambled, because if you do it this way, you're going to have something looking more like this, and then this is just rearranged into a different form. So what we're saying is this whole integral here is in this form. It's just the integral of f over g prime. But when you integrate this as a derivative, you're just going to get back f over g plus c. So all we need to do to finish this, we just need to grab our f value and our g value and put it in this form. So for my final solution to this, we're just going to have x over sine x plus cos x, add a plus c, and that's it. Okay, there it is, another good problem sent to me by Sid. Thanks everyone today for watching. Have a good day.